Congratulations, you've made it halfway through this course and halfway through the requirements of this exam. With computing and IT, we are never going to be too far away from a discussion on security. This section of the course covers security, privacy, compliance, and trust. We always have to have the security of our solutions in our minds as we're designing them, and this includes topics such as networks, firewalls, denial of service attack protection, and how to choose the right security solution. We'll start off in this video talking about the network aspect of security. So the next section of the exam says understand security, privacy, compliance, and trust, and is worth 25 to 30% of the total score. We can see on screen that this section has a lot of subtopics. So we're talking about virtual networks and network connectivity security, identity services such as Microsoft Azure Active Directory. We're talking about security tools and features of Azure, which are things like Key Vault, advanced threat protection, etc. There's the whole governance thing, which has to do with policies, RBAC, and Azure locks and things like this. We are also going to be talking about monitoring and reporting options because that's a big part of security in terms of understanding the threats that are occurring. And finally, privacy, compliance, and data protection. We live in a world where there's a lot of government and other standards that we need to put up with, including GDPR. And so having your environment that is compliant with these government standards and also your potential corporate standards is important to understand that section. So we have a lot to get through in this section of the course. So first we're going to talk about network security. Now, one of the fundamental aspects of network security is the concept of a firewall. Now, you might know, if you have any familiarity with networking within your own environment, the purpose of a firewall is to analyze traffic that is being directed to it and then either reject traffic that doesn't follow the permitted pattern or allow traffic through that does. So here's a diagram taken from Microsoft's site that shows a WAF, which is Web Application Firewall. And you can see that a number of requests are being made. On the left, only one valid request has been recognized, and there's been 2 requests. In this case, are SQL injection attacks and cross-site scripting attacks. These are both ways that hackers try to get control of your website. And so the web application firewall can actually detect these common vectors and actually just reject the request, and your website doesn't even get the attempted SQL injection requests. Now, on the right, once it goes through the firewall, those requests get sent to the correct location. You might have many different applications, many different URLs, and the load balancer that's represented by the level 7 load balancer in the middle would be able to direct the traffic to the right location. So the purpose of the Azure firewall is to basically block invalid attacks. Now, they could be attempted hacks, which are quite obvious, or it could just be making sure that nothing but port 80 gets through if it's a web server, or that the source of the request is on a whitelist, etc. There are many different rules that you can apply to your firewall. But having a firewall is one of the essential elements of networking security. And so if you're going to have a serious application available to the public, you should consider having an application gateway with a firewall. Another aspect of networking security within Azure, relatively new, is the distributed denial of service attack protection. Now, you might be familiar, this is abbreviated as DDoS. You might be familiar with distributed denial of service attacks in the real world outside of the cloud. That's where you have many different sources of an attack that are attempting to overwhelm and take over a resource so that no valid attempts can get through. So you might have 100,000 computers that have been infected by a virus and have been turned into a botnet that are all making the requests to the same server at the same time. And with 100,000 hackers, essentially locations, those valid requests that your users might be making can get lost in the shuffle. And that's why it's called a denial of service. So essentially the server becomes overwhelmed. Microsoft offers a distributed denial of service attack option. Now, there's the basic option. This comes with a monitoring package, the ability to do automatic mitigation for certain attacks based on the network level that it comes through. If you use the application gateway that we talked about in the firewall section, this is you can get what's called level 7 protection. That means that you can look at the URL and the URL and the type of traffic and be able to say, well, we allow, people to get to the /images directory, but we do not allow people to make requests for the /videos directory. And you can actually, down to the path of the request, do some types of rules. The denial of service attack protection is available globally. Now, if you upgrade from the basic level to standard, you are going to get policies that are tuned to your specific virtual network. You'll get additional logging, alerting, and telemetry that you can tap into. And it can basically detect that your resources are eating up a lot of cost. And basically that becomes a denial of service attack. If someone's making hundreds of thousands of requests to your Azure function, and that's outside the normal standard, then they're basically eating into your costs, and so you can use that for denial of service attack protection. Now, finally, the other thing that you should know about, and this is the most fundamental form of security protection on a network, is what's called a network security group. Within the Azure Resource Manager model, when you create a virtual network, you have the option of applying a network security group to that. Now, the network security group is a series of rules that you can apply that allow inbound traffic based on certain rules or prevent outbound traffic based on certain rules. So you might have on the same virtual network, you could have a front-end concept where all your web servers live and a back-end concept where all your application servers or your database servers, anything that's should not be public facing to the internet. And you can see in the diagram on screen that the NSG icon, the network security group, stands in front of the subnet level so that traffic coming in has to pass through these rules, and you can basically allow traffic to your front-end VMs and deny public internet traffic to your back-end VMs, and that would force traffic along a specific path. The other options for this is if you had a private network, like you had an express route connected between Azure and your offices, you could enable your NSG to basically block all internet traffic, and that would basically prevent the open internet from accessing your sites and applications and force it through your corporate network over the express route. So there's many different configurations, but a network security group is a fundamental piece of software that Microsoft allows you to enable that will basically set out inbound and outbound rules in which traffic can reach your network. Now, we saw with network security groups that ultimately you're defining a rule, and that rule is protecting a destination IP address by number. And so you basically specify that for traffic coming to this IP address and this port, these are the security rules that we want to enforce. But that's not really realistic when you're dealing with hundreds or even thousands and tens of thousands of devices on your networks. So then having to specify network security groups for every single web server, every single database server, every single machine on your network might become a little burdensome after a while. So Azure has introduced this application security group concept in which you can define the destination by role and not all by IP address. So if you want to create a rule that protects all virtual machines, well, then you can define that rule. If you want to define a rule for SQL servers, you can get a different rule. So we can see we've got web servers, application servers, DB servers, and then when you're defining the network security group rule, you can say this is the rule for web servers, and you don't have to specify them by specific IP address. Next up, let's talk about user-defined routes, or UDR. A user-defined route allows you to specify the exact path that some traffic needs to travel over your network. Now, an example of this might be a firewall. So perhaps you've got a physical firewall device, one of the virtual machines like a Barracuda firewall that you get from the Azure Marketplace, and you don't want internet traffic to travel directly to your VMs. You want it to be forced to go through that firewall device before it can talk to any VM. And in that case, you're going to specify a UDR, a user-defined route, that is going to force traffic to come in through that firewall before it can get to any of your devices. You can also define the traffic outbound so that it has to go through a firewall outbound before it gets to the internet. Another use case of this would be if you want traffic to travel over your corporate network to get to the internet and not directly from Azure out. So let's say you have an express route, which is a direct connection between your corporate office and Microsoft Azure, And if any machine within Azure wants to talk to the internet, you want that traffic to travel over your ExpressRoute gateway through the ExpressRoute into your own network and then out to the internet. And if you want that to happen, you can define that using AUDR. So you can use this to force traffic through a path, either inbound or outbound or both. The next requirement of the exam says to choose an appropriate Azure security solution. So we just went through a few of the options that Microsoft offers within Azure for securing your network and for securing your applications. There's a lot to do with security, and we're really only scratching the surface here in terms of the specifics. But here are a bunch of rules, general rules, that I'm going to suggest to you as being best practices for choosing security solution. First up, all virtual network subnets should use a network security group. So network security group is the most basic layer of allowing or denying traffic. You should make your network security groups fairly tight, so deny as much traffic as you can from ports and from sources that do not need to be accessing that network, and make it universal that all of your virtual network subnets have an NSG. I look at a network security group as like having locks on your doors and windows that you don't use. So if you don't use a port, don't allow traffic into your network on that port. And so there's many other security methods that you need to employ to be totally secure, but this is sort of a basic premise that you lock the doors that are never used. Now, this denial of service attack service that Azure offers, really, you should make your own analysis to whether your network, your application needs that. It does cost some money. Not every application is going to get a distributed denial of service attack on it. And sometimes you want to enable that only once you detected that you are likely to be a target or you actually have been attacked. That's probably a good policy. In terms of the application gateway with firewall access, of course, if you've got serious enterprise-grade applications, you're going to have to look at firewalls. Network security groups are great, but they're not going to be intelligent enough to know what traffic is likely to want to pass through or not. It doesn't have any AI pattern matching. It's not going to alert you if a brute force attack is underway, etc. So get yourself a good firewall. There's a concept in security called layered security or security through layers. And so it's not good enough just to have one security guard, one layer of defense. If an attacker is able to get through your one layer, then they have full control of your application and your network. What you want to do is make sure you have security in layers. Later on in this course, we go through security in a bit more detail, and we're going to talk about all the different layers, the options that you have for putting security through the different layers.